20.4, the intermediate value theorem. Okay, well, let's read it first. Frank, go ahead.
Given a polynomial function f of x continuous on
interval, yeah, AB,
AB, and f of a is less than w less than f of
B.
b, there exists a value c where f of c equals w and a is less than c less than b.
Thank you, right? In short, that C is in between the interval AB, right? So, graphically, what does it mean, right? So we need to visualize this, okay? So for example, let this be your function f of x in green, okay? So as you may notice, it is continuous, right? When you say continuous, from A to B, those are the x values, right? The part of the domain, right? From A to B, see this part of the function or the polynomial function, it's continuous, right? It doesn't break. It doesn't have, the sharp turns. We good? Okay. It's not discontinuous, right? It should be continuous, right? Now, there must be, right? So since this is A, the x value, then f of A is its y coordinate. Are we good, guys? Get it? Okay. Since this is B, given, then f of B is its y coordinate as well, right? Okay. Now, there's also a given W, right? And that W is in between f of A and f of B, right? So if this is f of A and that is f of B, then W must be somewhere in between them. Are we good? All right, so that's why this inequality in here, right? Then, that means, since W is a y coordinate, right? If you trace it back to the function, then there exists, right, an x value, right? Let's call it C, right? There exists an x value, C, such that that C is in between these two given values of x, a, and b. Okay? Now, let's see now. How do we use this IVT or intermediate value theorem to answer numbers 24 and 26? Okay, well, let's read the instruction first and see how we can work on this one. Okay, Rachel, can you read our instruction for such?
For the following exercises, use the intermediate value theorem to confirm that the given polynomial has at least one zero within the given interval.
Thank you, right? There we go. So use the IVT, let's call it the intermediate value theorem, right? Confirming that the given polynomial f of x, right, has at least 1 0, right, within the given interval. Okay, well, let's try it out. Number 24. Okay, let's try it at number 24. Let's read number 24 in here, okay? Edward, let's read number 24.
F of x is equal to x squared.
X cubed?
X cubed. Sorry.
No
Read
problem.
it from the board.
Yeah, it's just
minus 9x between x equal minus 4 and x equal minus 2.
Thank you, right? So negative 4 and negative 2 are the two x values given, okay? Now, let's read this one, right? How to analyze the function by intermediate value theorem, right? Let's read the first step. Angelina.
Determine A and B values.
All right, and the A and the B values are the leftmost and the rightmost values of x, right? So with that being given, what x value is the leftmost value? Which is A and which one is B?
-4.
There, right? So in there, A is -4 and B is
-2.
-2, right? Okay. Right? So this is the leftmost and this is the rightmost value, right? Are we good, guys? Okay. Next, step number 2. What do we do then for step number 2? Niste, let's read this one.
Evaluate FA and FB.
Thank you, right? So evaluate the function at these two values. Get it? So that you can get these two, right? Because if you got your A and B, you need to evaluate now FA and FB, right? So let's evaluate at A first, right? What's f of A?
4 cubed minus 9.
Yep, that's correct, right? But again, do not forget the negative, right? Negative 4 cubed minus 9 times negative 4, right? So what's that gonna be? Okay, calculator, right? So you just plug it in there, right? Negative 4 cubed minus 9 times negative 4. Okay? Use your calculators for such. What's that gonna be, guys? Okay? Oh, what you got?
28.
Positive 28?
Negative 28.
Negative 28. Yeah, because this one is 36, right?
Mhm.
Right? And this one is what? Like minus
Negative.
64, right?
Yeah.
And so what you got again, Angelina?
A negative 28.
Negative 28. Well, we're gonna do the same at b, right? Evaluate the same function f of x at b, right? So there we go. What's this again? Just the same as that one at negative 2, all right? Negative 2 cubed. Do not forget the parenthesis, okay? And you put in the exponent outside the parenthesis as well, okay? Okay, calculator. Let your calculators be useful for that. Negative 2 parenthesis cube minus 9 times negative 2. Okay, calculators once again. Okay, you got an answer for that one?
No. Still write it down.
Okay. What do you think, guys? So this is negative 9 times negative 2 is positive 18, right? Okay. And this is what? Negative 8, right? So what's that gonna be?
10.
Positive 10. Very good, right? So verify on your calculators. You're gonna get a 10 for such. Okay, guys. Okay. Okay. So check, we have done step number 2. We have evaluated the function, given function, at A, the leftmost value of x, and at B, the rightmost value of x, right? Are we good? Okay. Let's answer, let's consider step number 3. Right, Robert, can you see step number 3 in here?
If f of a and f of b are different signs, then f of x equals 0 exists between a and b.
Thank you, right? There we go, right? Since f of a is negative, that we don't actually care about the value, right? As long as your y value, the first, is negative, and the other value is positive, they're of different signs, then we know that at some point, it hits the x-axis. Are we good? Then that means that's at one point, it is a 0. Are we good? Right? So with that being said, then we can say in here, we can compute for that one now, right? So in here, we can say in here, solve for x, right? So let's consider in here, solve for x. And what is that x, right? So put in here. Well, let's solve for that x, right? So and what is our function again? We got what? X cubed, right? So that's your, what's this? F of x, which is x cubed minus 9x is equal to 0. Are we good? Right? Well, we can solve for x for such, right? So what do we do with this? Well, I would say since these are both having x's, we can factor out the x, one of them x's. So factoring out x, we have in here the following, right? Again, they're common x values, right? X times x squared minus 9 is equal to 0. We good? Right? And with that, we can solve for x separately for such, right? So by product, zero product rule, according to this one, either x is equal to 0, okay? Either this is equal to 0, or this one, x squared minus 9, is equal to 0. Are we good, guys? Again, by zero product rule, if this number and this number is equal to 0 and multiplied together, then that only means that either this is 0 or this is 0. Are we good? Again, zero product rule. And with that being said, it's already solved for, right? How do you solve for x in here? What do we do then? Add 9 on both sides. Very good, Rachel, right? So plus 9 on both sides. Cancel this. X squared is equal to 9. Well, we just want the x, right? How do you get rid of that power 2 or square?
Square root.
Square root, both sides. Very good, Edward. Let's let me call, get this green in here. Square root both sides. Oops. Okay, there's no more green marker. And definitely, since x squared, the square and the square roots are inverses, you can cancel them out. But in here, square root of 9, what's that going to be?
3.
Very good, Edward, right? 3. But again in here, do not forget the plus or minus. Are we good? Get it, guys. So we have solved for x, in this case, x's, right? We have 3 values of x's, right? Now, step number 5. Well, we have 3 x's. Are those x's all correct? Let's read step 5, right? The last step in here. Sean.
Choose x that is between A and B.
A and B, right? So again, your A is what? -4, right? Your B is what? -2, right? Now, which among those x's, 0, 3, or -3, is in between -4 and -2? Negative. Are we good? So in here, the answer is what? Answer x is equal to -3. Right? Why x equals -3? Why not x equals 0? It's not in between -4 and -2. Right? Again, it says in there, in between. Right? You see the word between, right? Why not +3? Well, again, it's not in between -4 and -2, right? So only -3. Are we good, guys? Well, let's see. How does it look like, right? We can actually verify it by graphing. So let's see how the graph looks like in here, okay? So once again, what's our function? We said x cubed minus
9x.
9x, thank you. Put in here. So how do we visualize that one, right? X cubed minus 9x, alright? So here it is, okay? But we're only concerned with what x values? -4 to -2 only, right? So if you can recall our piecewise function, we're gonna cut this into only that piece, right? So curly bracket. Can you recall the curly bracket once again, guys? -4, right? And then what else? Less than or equal to x less than or equal to -2. Okay, once again, recall your see that part? Okay. So if I want to clearly see it, it looks like the maximum is 10 and the minimum is like, I think, almost -28, right? So I can change this one. My x-axis once again is from where? From -4 to -2. Good, right? And my y-axis from where? A while ago it says -28 to 10, right? So I'm going to put in here the following: -28 for the y to 10, right? So only that part of the graph, right? Okay. Now where is your f of x equal to 0 in here? Well, where did it hit the x-axis? At -3. Right. There we go. So that means that is your, once again, f of x is equal to 0. Right? Which confirms our answer a while ago, right? So not +3, even if it's still also 0. Not 0, even still is 0, right? But only -3. Simply because this one is the only one that is in between -4 and -2. Are we good, guys?